Today we will be learning how to graph sine and cosine, as well as writing the equations when we are given pieces. So first, let's dive in and look at the attributes for graphing trig equations. This looks much like what we learned at the beginning of this year, where we discussed transformations with the A, B, C, and D transformations. The only thing different here is just the names of them. Instead of a vertical stretch or shrink, we would refer to that as the amplitude. So you may need to pause and write down this information if need be, but the absolute value of A out front is the amplitude. If A is negative, we know that's a reflection over the x-axis. The B value is the number of cycles that occur between 0 and 2 pi. The period, the formula for that would be 2 pi divided by the value of B. The phase shift is our left or right translation, and then vertical shift is our up and down translation. Here is the parent function for sine, and I've copied the unit circle over, where we know from earlier in this unit that sine is the y value. And so when I'm graphing sine, I'm just picking 5 points. And so I'm picking all of the x and y axes. So 0, pi over 2, pi, 3 pi over 2, and we know a full circle is 2 pi. So looking at the y values of the coordinates, or the sine values of those coordinates, we would have 0, 1, 0, -1, and back to 0. So that's how I get this parent function table. And then I can graph that accordingly along my x-axis. I'm labeling 0, pi over 2 pi, 3 pi over 2, and 2 pi. My height, the max would be 1, depth, the min is -1, plotting those points. Let's go ahead and graph a transformation of sine. So I've got the starting 5 coordinates already put into the table, and I need to identify some information. So the amplitude we know is the absolute value of A, and in this case, A is -2, so the amplitude is 2. The formula for period is 2 pi divided by the B value, and in this case, the B value is 4. So 2 pi divided by 4 is pi over 2. In this particular problem, we do not have a phase shift or a vertical shift, but yes, we do have a reflection over the x-axis. Now I need to go ahead and apply these transformations. So this value -2 is outside the parent function, so we're going to multiply all the y values by -2. We're applying the vertical stretch of 2 essentially, as well as the reflection, both at the same time since they're both multiplication. Then for my x values, I'm going to multiply those by the reciprocal of b, just like we did at the beginning of this school year. So the reciprocal of 4 is 1/4. I would get 0. Pi over 2 times 1/4 would be pi over 8. Pi multiplied by 1/4 is pi over 4. 3 pi over 2 multiplied by 1/4 is 3 pi over 8. And 2 pi multiplied by 1/4 would be pi over 2. You'll notice that we'll get one full period of sine from 0 to pi over 2, which is also our period. Then labeling my x-axis starting at 0, then we have pi over 8, pi over 4, 3 pi over 8, and pi over 2. My max and my min are 2 and -2 respectively, and then we would graph. We're starting at the origin. We'll travel down first, back to the origin, up to our max, and back down. Or I guess not the origin, but the x-axis. And then we'll graph one full period. We can put arrows at the ends of these because we know this function's continuous, so we'll continue on from to positive infinity as well as back to negative infinity. Next, let's look at the parent function for cosine. Very similarly, cosine is a periodic function. It continues from negative to positive infinity, but here's just one snapshot, one period of cosine. Cosine is the x values around the unit circle, so I'm picking the x and y axes again and looking at the x values. So I have 1, 0, -1, 0, and 1 for my parent function. Transforming cosine is very similar. We can go through and answer some questions, but we have to be sure that we are in standard transformation form. So we need to make sure that this 2 pi is separated from the variable theta or x or whatever that might be before we can do any describing. So I'm pulling the 2 pi away from theta, which means I also need to factor that out from the value of pi over 2. So I would take pi over 2 and divide 2 pi out of it. That's the same thing as saying pi over 2 multiplied by the reciprocal, 1 over 2 pi. So I would get pi over 4 pi, and my pi's cancel out, and I get 1/4. So that's the value I can put in right here. Okay, the attribute's absolute value of A in this case. In front of cosine, I just have a constant of 1 that's shown, so the amplitude is just 1. The period formula is 2 pi divided by the B value, and the B value is 2 pi in this case, so the period is 1. My phase shift, that's the left and right behavior here, so the phase shift would be a positive 1/4. We could also refer to that as right 1/4. For matching what we did back in transformations. We do not have a reflection for this function, but we do have a vertical shift, and we're moving that guy up 1. So here we go with our transformation. Applying the transformations, I'm going to look at what we need to change inside the parent function first. And inside the parent function, I have a nice value of 2 pi. So I'm multiplying by the reciprocal of 2 pi. That's the B value. So 1 over 2 pi is what I'm multiplying all of my inputs by. Pi over 2 multiplied by 1 over 2 pi. That will give me the value of 1/4. Pi multiplied by 1 over 2 pi would be 1/2. 3 pi over 2 multiplied by 1 over 2 pi gives me 3/4. And then 2 pi over 2 pi is just 1. So from 0 to 1, and the period is 1. The next thing we need to do is move everything to the right 1/4. So we need to add 1/4 to all of these values. So I have 1/4, 1/2, 3/4, 1, and 5/4, or 1 and 1/4 if you like mixed numbers. Then at the back of my function, I don't have anything I need to multiply out front, so I'm just going to add 1 to the end, notching everything up 1 unit. So it looks like the max height is 2, and the min would be 0. And then along my x-axis, I'm labeling 1/4, 1/2, 3/4, 1, and 5/4. I have to create one extra point. You'll need to do that as well on your graph. All right, and then we would plot the 5 coordinate points. At 1/4, we're up at 2, slowly moving down to 1, then 0, and then back up. So it's important to make this shape look more curved than an absolute value function. You don't want it to look too pointed. And there we have it. The second objective today is writing equations given pieces of information. So we know that the period formula is 2 pi divided by b. So if I were to cross multiply and divide, the value of b is the same thing as 2 pi divided by the period. We'll need that in just a few moments. So this question says write the equation of a positive sine equation with this information. So I like to just kind of fill this in, leaving spaces for everything. So that would be a space, leaving some more spaces. You can use the value x or theta. 4 spaces for my 4 variables, a, b, c, and d. So I know a is the amplitude, and I'll put that guy out front. I know it's positive 4 because it says write a positive sine equation. All right, P would be the period, which I'm going to skip for right now. Moving on to PS, which is the phase shift. A positive 2 pi over 3 means we're moving to the right 2 pi over 3, so I have to put a minus sign in right there. And then a vertical shift down 1 minus 1 at the end of our function. So then this 4 pi is not the same thing as b. The period is not the same thing as b. So that's where we use this. I'm going to take b and say, okay, b is equal to 2 pi divided by the period, which is 4 pi. This reduces nicely to 1/2. So I put 1/2 in for that equation. Let's do a second example. This one says find a cosine function with the given information. So again, I'm writing out, leaving some spaces with cosine. You can use x or theta there. And we've got variables for a, b, c, and d. So in my problem, it says that it has an amplitude of 2. I'll plug that right in. Shifted down 3, I'll plug that right in. And a phase shift of 4, it's a positive phase shift to the right, so we'll put in -4 to show we're moving to the right 4. So then we need to take this value, the period is 4, and we know that b is equal to 2 pi divided by the period. So that reduces to pi over 2. And that's what I can plug in right here. Now, one last thing I want to mention before we end today is sometimes the final answer for these types of problems will be redistributed through. And so just be comfortable if you see it looking something like this. Minus, let's see, 2 pi minus 3. These are both the same equations. One is factored out, the other is distributed